All right, here's your key to your study guide that I'm going to work through step by step. So if you did it in class or at home, make sure you go through this to check before you have your quiz later this week. All right, so here we go. So when graphing, when you graph an answer, if the sign is either, you could say greater than, or more than, right, or less than, or fewer than, those are common words, then the dot is not shaded. If the sign is greater than or equal to, or less than or equal to, then the dot is shaded because that includes the number as a solution. Okay? Let's go to part one. Translate each inequality into words. You could say F is greater than or equal to. That's the common one, but we won't really talk like that, right? We're going to use things like minimum, a minimum of -4, or at least -4. Those are a couple common ones. Number two, a number D, some number is fewer than, right? You can say fewer than 6, less than 6, below 6. And then the third one, G, a number is less than or equal to 0. You could say a maximum of 0. Notice 1 and 3 are exact opposites of each other. And or at most, no more than, there's a couple more. But there are a couple of words, common words that we use when we talk. Okay? All right, the second section, we're just going to take these phrases and write them as an inequality. Okay? So I'll just go through and do the correct signs, get myself straightened up here. Oops. All right, here we go. Number 4, all numbers. I'm going to use x as my variable, same variable every time. Greater than or equal to 6, that means the mouth opens to the x. All numbers that are less than 5. There's some numbers that are less than 5. All numbers less than or equal to 7. That one. All numbers greater than -11, mouth opens to the x. Okay. Let's go do the last 3. There are less than 25 people, less than 25 people in class. The trip will be more than. This is a common one where students do the greater than or equal to. More than can't include 4. It's got to be more than 4. It can be 4 hours and 1 minute, but it doesn't include 4 on there. And I will need to save at least $100 for my trip. There is your first page of your study guide. All right, page 2. Just matching. So I'm looking at these. Gonna let the focus hopefully focus in. It doesn't look real focused to me, but let's see. There, that looks a little better. All right. Well, it looks when I look at those 4, I look at 1 and 4. Those are my hollow dots. It looks like 2 and 3 are my solids. So hollow dots are C and D. Number 1 is less than -1. That's going to the left from -1, so that is C. And I'm going to go down and do the other D. Goes down here because that's greater than -1. And then it looks like less than or equal to 1 is A because of the solid dot and goes to the left. And then, so it looks like it's C, A, B, D. Okay. Bottom section, write the inequality. It's a hollow dot. Numbers are going to the right, so it's all numbers that are greater than -2. Looks like number 6, solid dot. Looks like all numbers that are greater than or equal to 5. And then 7, it looks like solid dot because so it's less than or equal to, and it's on 2, so that is less than or equal to 2. We're just going to call this -7. Okay, or maybe they're calling this 0. I don't know. I guess we'll assume that's 0, so I'm just going to go over to -7. Call that -7. Solid dot on -7, and I'm going to go up and to the right because it's all numbers that are greater than -7. Next one is x is less than 14, so we'll make this 14. We're going to do a hollow dot. We're going to go up and to the left. And then the last one, this is kind of tricky, right? I like to flip it. I like putting the variable first, so mouth is opening towards the x. Doesn't mean you can't do it this way. I'm sure you could. Go to 6, hollow dot on 6, but it is all numbers that are greater than 6. So it goes that way. All right, there's your second page. All right, next page. 2 more to go. So we just got a bunch of solving here. All right, so basically number 1 or number 7. Is that right? Oh, sorry. I'm going. Wait, no. All right, we're right. This is part 3, part 4. This goes a little bit out of order. All right, so we're here. Sorry. Back to it. So it looks like I'm adding and multiplying in the problem. So to undo that, do it in the correct order, right? You gotta subtract. Okay. So in order to get n by itself, we've got to subtract and divide. So we're going to subtract 16, subtract 19, not 16. And we bring down our 2n, not a flip. 2n is greater than 6, n is greater than or equal to 3 after we divide both sides by 2. Okay, n is greater than or equal to 3. Solid dot on 3, we'll call this 3, and up and to the right. Next one, looks like I'm adding 14 and then dividing by negative 3. So we're going to subtract 14, right? Make sure you get this correct. Negative 3x is a flip, so we're going to flip it here. Is less than negative 22 minus 14. That's like adding them together. That's negative 36. Divide both sides by negative 3. And you're going to get x is less than 12. But don't forget to flip. Go to 12. We'll just call this 12. Hollow dot on 12. Up and to the left. Okay, next one. We have to undo multiplication and subtraction. If you want to flip it to the other side, if you want to put the 5y minus 3, some students like doing that. Just make sure the mouth opens to the 5y. It's not a flip, right? Because we're multiplying by a positive. Add 3, you get 5y is greater than, 145. And you're going to divide both sides by 5. And you get y is greater than, what is that? Y goes into 14 2 times 29. Y is greater than 29. Call this 29 up and to the right. Yeah. Next one is a flip, right? Because I have that negative 2r. I'm going to add 4. Add 4. I'm going to go ahead and flip it now so I don't forget. Greater than or equal to negative 6. That's subtraction. Keep the negative. Negative 2. Divide both sides by negative 2. And you get r is greater than or equal to 1. Solid dot on 1. Call this 1. Up and to the right. All right. This one we have some decimals, but it's not a huge deal. Remember, you can put the m plus first, but if you want to go ahead and subtract 5 and 7/10, subtract 5 and 7/10, you get m is not a flip, right? Not even multiplication or division in the problem. So let's see. This becomes negative 8 3/10 plus a negative, adding 2 negatives. That is m is greater than or equal to negative 14. Solid dot on negative 14. We'll call this negative 14. Up and to the right. And then the last one, we have addition and division in the problem. Not a flip, because there's no negative with the variable term. Subtract 8. Subtract 8. We'll get x over 2 is less than or equal to negative 20. And then we're going to multiply both sides by 2. Multiply that by 2. And we get x is less than or equal to negative 40, I believe. I've done everything right. I think so. So we just go to negative 40. Solid dot. All numbers that are less than or equal to negative 40 goes that way. All right, there's your third page. Sorry if you couldn't see that graph. And then the last page, so we got a couple, put it all together really with solutions. And then we have one word problem. All right, this one just gives you a graph and asks you about solutions. So this one basically, does the line contain these numbers? The only thing that's tricky here is just know that -2 is a solution, right? Because that solid dot on -2. So is -4 part of that? No. Is 0 part of that line? Yes. And yes. Okay. There's your first one. Next one has a little bit of work. I would just solve it. You could plug each of these in. So there are some students that could do the first two, or could maybe do all three of them, right? So I'll solve it to the right. So we have D plus 3.9 is less than -3.3. Well, then we do have to subtract 3.9, 3 and 9/10. Well, that is actually adding together. So D is less than -7 and 2/10. So it's all numbers that are less than -7 and 2/10. Now, that will definitely help you with C. But the first two you maybe could have done without this to the right, because some of you may have just been able to put 2 in here. 2 plus 3.3 and 9/10 is 5 and 9/10. Well, a positive is never less than a negative, so this one's no. But it also fits here, right? It fits over here too. 2 is not less than -7 and 2/10. 0, well, 0 plus anything is itself. Well, 3.9 or 3 and 9/10 is not less than 3 and 3/10, so that's no. And you'll see it also works here, that 0 is not less than a negative. 0 is greater than any negative number. And then the last one is -5 and 1/10 a solution. Well, you could do -5 and 1/10, okay, plus 3 and 9/10, maybe mentally in your head. You might know that that is -1 and 2/10. If you do, you'll know that -1 and 2/10 is not less than -3 and 3/10. It's actually greater. So all three of these are no. But you could also look here, right? You could put it here now that we solved it. -5 and 1/10 is obviously not less. And -5 and 1/10 is a little bit closer to the positives than -7 and 2/10. All right. All right, here's your last one. Okay. So let's read it. Good thing to do with all word problems. Nick's got $7. Bagels cost 75 cents each, and each small container of cream cheese cost $1.30. Write and solve to find inequality. Define the number of bagels that Nick can buy. So define a variable. So we're just going to do bagels, right? I've told my class, short and sweet here. All right, just get to the point. Write an inequality and solve. So basically, bagels plus cream cheese has to be, he only has $7. So let's start with the inequality first. It's got to be less than or equal to 7. All right? Here's the bagels. Here's why we define that variable. Bagels, right here with the 75 cents each. You just got to know that we write that as 0.75x plus $1.30 must be less than or equal to 7. And now we have a little bit of math to do. All right? So we've got to, not a flip, so we're going to subtract $1.30. We're going to subtract $1.30 from here, right? If you remember, got to line up your decimals, and you're going to get 0.75x is less than or equal to, well, that is $5.70. Well, this isn't going to come out evenly already, I know, I believe. So we have to divide by 0.75, we have to divide by 0.75. I'm going to actually show you the long math, all right? So we take 5.70 divided by 0.75, and let's see, we do 1, 2 to the right because we got to move that. It's basically 570 divided by 75. Doesn't go there, doesn't go there. And I believe that this is, that's 7. Let's try, I think it's 7. Let's go 5, 3, that's 525. And what is that, 45 left over? Well, now we have a decimal to 0. Well, you're going to notice that it's 7 point something. So let's just see if this is 450. Well, we really, the number of bagels, it's got to be less than, to enable for us to be able to buy these. We can buy 7 point something, but it's got to be a whole bagel. So we're going to say you can buy 7 bagels. All right, I don't know that I explained it that well. But you can't, the store's not going to let you buy a part of a bagel. So your correct answer is it's got to be less than or equal to, if we were going to write this 7 point, whatever that is, we'll just say 5 for the sake of argument. Well, you should write 7 bagels. All right, that's 14 minutes. I know that's a long long listen, so hopefully this helps you for your quiz on later this week.